All right. Thank you, Daniel. So as Daniel said, I'm Kelly Nicole, the Watershed Coordinator at EOS, and today I'm going to be talking a bit about our work in the Cape Tormentine Peninsula Watershed. So to introduce EOS a bit more, we're a small nonprofit organization based in Sackville, New Brunswick. We serve the Memramcook-Tantramar region and beyond, and we work on a variety of different projects. So that can include watershed management, energy sustainability, renewable energy, sustainable community planning, and climate change adaptation and mitigation. But all of those things can be linked back to really empowering local solutions to climate change. The Tantramar region is actually one of the most vulnerable regions in New Brunswick to climate change due to our low-lying and coastal location. And we're going to be primarily seeing those climate change impacts through water. So what I mean by that, we're going to be having more extreme, more frequent weather events, so more precipitation, which could be leading to flooding, storm surges, which is also increased with sea level rise. So these pictures here on the slide show some issues, these impacts we've actually seen here in recent years. So that can include storm surges, almost overtopping the dikes here in Sackville, lots of coastal erosion in Port Elgin and up along the Northumberland Strait, as well as just general inland flooding of roads, people's basements. And on the flip side, we're going to also be experiencing warmer temperatures. So similar to this summer, we're going to be seeing an increase in drought periods. So this June was actually a record-breaking month for the least precipitation on record, and much of the province was under a severe drought warning throughout the summer. So climate change is not only going to be impacting water quality, but also water quantity, and really magnifying existing challenges and leading to new ones. This slide shows some of our biggest threats right now within our watershed. So that includes clear cutting, agricultural practices when there's lack of riparian buffers, and algal blooms are another one that's of a concern. While we haven't had a positively identified cyanobacteria bloom here within our watersheds, we have had them in the neighboring areas, so in Moncton and this past summer in the Amherst area as well. So with our rising temperatures and favoring conditions, that's definitely a new challenge we're being presented with. So all these reasons are really why starting a long-term water quality monitoring program is so important. We really need that better understanding of watersheds to prepare our communities for the impacts of climate change. And we need that sound science-based data to really make sure we're making good decisions. We want to ensure the long-term sustainability of our watersheds by preserving and enhancing the water quality. And most importantly, in our area, there's actually been no previous monitoring of water quality in the Tantramar region, so no baseline exists, which is why we need that data to really move forward. So in 2017, EOS established the Chignecto Watersheds Committee, a technical advisory committee made up of local experts who bring a wide range of expertise to the table. And together we work to start up the Chignecto Watershed Monitoring Program. I do realize there's a wide range of understanding here today, and people might be coming in and out of presentations. So I just wanted to go over what a watershed is again. So a watershed is an area of land where all the surface water is draining from the same place. So it includes all the land as well as all of the waterways, and it's really dependent on the elevation. So water will be flowing from the high points down to the low points. This map shows the watersheds that EOS is monitoring. So the Chignecto watersheds, the watersheds bordering the Chignecto Isthmus. And these watersheds also down the Tantramar River watershed area are bordering where the Petitcodiac Watershed Alliance monitors. And then up the Cape Tormentine Peninsula area is bordering where Vision H2O, the watershed group out of Cap Pelé, monitors. So this is quite a large area with many waterways. It's just over 1,000 square kilometers, and that actually doesn't include an area we expanded out to this year, which includes Dorchester. So because of this, and to get a really strong baseline, we've been tackling the monitoring on a sub-watershed basis. So we started in 2018 with the Tantramar River watershed. 2019 was the Cape Tormentine Peninsula Watershed, so what I'll be talking about today. And this year we were doing the Rockport Dorchester area. So the map doesn't show it yet, but down at the bottom peninsula there, the Johnson Creek watershed actually extends over to Dorchester. The Cape Tormentine Peninsula Watershed covers almost half of this area, so just over 450 square kilometers of land, has a total watercourse length of 328 kilometers, and it's a part of the larger Northumberland Strait watershed. So all the water in this watershed ultimately flows into the Northumberland Strait. We were really lucky for the Cape Tormentine Peninsula Watershed because we got to team up with Dr. Doug Campbell at Mount Allison University and his research lab to do a citizen science water quality, a series of blitzes actually. So this was a really great project which allowed us to meet community members and cottagers from all throughout the watershed, and together we were able to start collecting preliminary data. So when I say a water sampling blitz, it's similar to a bio blitz, except we're trying to get as many samples, data points of water quality throughout the watershed in one day. So to do this, we set up a table at 4 different locations throughout the peninsula. So Bay Verte, Port Elgin, Cape Tormentine, Murray Corner, and community members were able to come grab a bottle, grab a water testing kit, and then go sample somewhere a body of water that was either fresh or salt water, but somewhere they were interested in. So maybe where they swam, fished, paddled, or even somewhere they just pass on their daily walk. But basically they'd go take a sample and then bring it back to us with a GPS point. So we also had instructions for how to get that on their smartphone. And then I took the samples back to Mount Allison University to the Campbell Lab where they were analyzed for coliform bacteria. And these blitzes, we actually did 3. We did 2 in the summer of 2018. The first one was actually under torrential rainpour conditions, but we still had amazing participation. I think we still had 40 to 50 people come out. And then we did a second one about a month later under dry conditions, so more normal conditions. And we had all returning samplers as well as some new ones. And it was such a success that we did a repeat blitz in the summer of 2019. And we would have done one again this year, but it wasn't exactly COVID friendly. So what we were measuring or looking for, I guess, was coliform bacteria, so E. coli and Enterococci. E. coli doesn't survive as long in salt water, so Enterococci was measured when people sampled saltwater or brackish sites. And these are types of fecal coliform bacteria, so mainly found in poop. And they enter the water through runoff from sewage systems, wildlife, farms. So if there's cattle grazing in streams or manure just freshly applied. And these E. coli especially enters the waterways through runoff after periods of significant rainfall. So usually just over 10 millimeters is considered that. So the day where you did the blitz with torrential rainfall, that was really like the worst case scenario. So it was really interesting to compare that data to then the dry conditions a couple weeks later. And this slide really shows how valuable citizen science is. On the left is a map showing the data that we would generate following a blitz. So there's over 50 samples taken across the watershed and even some beyond the watershed boundaries. So people were so interested and invested in their water quality, they came all the way to take a sample, and then compare that to the map on the right, which is what I would be doing if I was going out just by myself. So the 12 sample sites throughout the watershed. So you can see citizen science really helps us cover a larger spatial area, which leads to more data and a stronger baseline of information on the watershed. And not only that, but it also educates citizens how to sample water quality and gives them a better understanding of water quality and issues within their watershed. And by going out and collecting their own samples, citizens really become connected and invested to water bodies in their watershed and become caretakers of the own environment. So this map here are actually showing some results from our 2018 water quality blitz. So the circles represent the concentration of E. coli or Enterococci, and the bigger they are, then the more that is present. And the ones that are red, those are surpassing the Health Canada recreational water quality guidelines, which for a one grab sample is 400 most probable numbers for E. coli and 70 for Enterococci. So as you can see from the map, we were able to identify a couple areas of concern. In particular, Scott Brook and Trout Brook were areas of interest since they were above the guidelines at both the outflow as well as inland for those water courses. So using the Blitz water quality data, along with talking to community members, land use maps, and really trying to find a mix of impacted and less impacted or more natural sites, got the watershed committee to this decision that these were the 12 sample sites for the area. So you can see that we chose 2 sites on both Scott and Trout Brook, since they had been identified as areas of concern. And we also had 2 sites on the Gaspereau River, as it is the largest river within this watershed, and also had significance where it runs through Port Elgin and has a number of cottages along it. And so these 12 sites were what we actually sampled during 2019. So how we collect water quality data, we take what we call in situ measurements. So we have a multi-parameter probe that we drop into the water that gives us readings such as water temperature, pH, so how acidic, how basic the water is, dissolved oxygen, conductivity, so the ionic content, things like chloride, sodium, basically the water's ability to conduct electricity. And then salinity and total dissolved solids, which are calculated off of the conductivity readings. And we took these measurements from our 12 sites from May to October using our handheld probe. And these, that was basically to try to capture a spring, summer, and fall representation of in situ water quality. We also got funding through the New Brunswick Environmental Trust Fund to actually collect samples in sterol bottles and then take them to the RPC lab in Moncton to get a whole other set of surface water analyses to get that really strong baseline. So things like our nutrients, bacteria, so the E. coli, as well as total organic carbon, all the surface water metals, as well as any other anions. And once we get all that data after the field season, during the winter, we look at all our results. We compare them to New Brunswick provincial guidelines, CCME water quality guidelines for the protection of aquatic health, as well as Health Canada guidelines for recreational activities in the case of bacteria. And then we write our annual water quality reports. So these can all be found on our website, which I'll link at the end. But they are quite thorough. There's a lot of data, usually like 3,500 data points per field season. So for now, I'm just going to highlight a few of the key results. So say things we're having issues with or things of interest. But if you want to see all the results, I'd recommend pulling up our report on the website. So water temperature, this parameter is dependent on many factors. It can vary depending on the season, the time of day, how big the water body is, how much shade it's getting from water vegetation, and much more. And as you can see from this graphic, it's also one of the most important parameters to monitor because it really has an overarching impact on all other water chemistry. And we'll talk about some of that in a bit. This graph is really busy, but it basically shows the water temperature for all of our 12 sites over the 6 months of monitoring. And the red line that you see there at the top for 20 degrees Celsius is the CCME guideline for the protection of aquatic life. So you can see our water temperature typically followed seasonal variation. So there was an increase in temperature during our warmer summer months, and it was cooler in the fall and spring. It did exceed the recommended guideline in July and in August. So 6 sites exceeded the guideline. So that's half of the sites in July, and then 2 sites exceeded it in August. And this corresponded with the increase in air temperature, so it wasn't too much of a surprise. Dissolved oxygen, so this is the amount of oxygen that is actually available for aquatic life in the water. And the amount of oxygen in the water is impacted by things such as water temperature. So as water increases, dissolved oxygen actually decreases. So with those warmer temperatures, we'd be expecting to see less dissolved oxygen available. Oxygen also enters through movement of water. So when we're seeing low water levels, slow, stagnant water, we'd expect it to also have lower dissolved oxygen. And water can also get in, oxygen can also get into water through photosynthesis from aquatic vegetation. This table here shows our dissolved oxygen concentrations over the 12 sample sites from May to October. And any of the numbers that are highlighted in red indicate that the dissolved oxygen concentrations are below the New Brunswick guideline for aquatic health of 6.5 milligrams per liter. So you can see quite a number of samples were below this guideline, but definitely more prominent in July and August, so corresponding to the 2 hottest months according to our temperature data, with 7 sites, so roughly 60% of the sites in July were below, and 75% of the sites in August were below. And then our third most frequent, I guess, would be September, where we're still seeing those warmer water temperatures as the water's just starting to cool. And this is showing the data a little differently, but I thought it helped highlight what some of the potential issues were within our sites. So this graph is showing us the average dissolved oxygen over the 6 months for each site. And the red line again is showing that guideline. And you'll notice that there are 5 sites that are on average below this recommended guideline. So what's interesting is near the middle of the graph, so Scott Brook and Trout Brook off of Route 955, both of these are tidally influenced sites. While we sample at low tide, these sites were still particularly brackish. I'll touch on this in a bit, but the solubility of oxygen in seawater is actually about 20% less than it is in freshwater of the same temperature. So that could be why these sites were on average below the dissolved oxygen guideline. So in addition to the higher temperatures, it's also salty, so less oxygen overall. And then the other 3 sites that were on average below the guideline, Blacklock Brook, Trout Brook off Murray Road, and McKay Brook, are all smaller, slow-moving streams, with Trout Brook actually having a note that it appeared stagnant in the warmer months because the water levels were so low. So again, we mentioned oxygen enters water through that movement, that agitation. So without any movement, low stagnant water, we're going to be seeing lower dissolved oxygen. E. coli. So there's definitely an issue with E. coli within the watershed as well. This table shows the concentrations from June to September, and the red numbers are the ones that are above the recommended guideline. I would have put it in a bar graph, but some of the values were so high, they were just on the cusp of the detection limit, exceeding it, so it just would not have been a good scale. But from this, you can see that aside from June and September, which each had one site that surpassed the guidelines, July and August had the most number of sites surpassing the guideline, which again correspond with the warmer temperatures and lower water levels, which can lead to concentrating some of these things. And then another one of our issues within the watershed is phosphorus. So this is one of our nutrients that we measure. We also get concentrations for total nitrogen, ammonia, nitrate, and nitrite. But we seem to have a particular issue within our watershed with phosphorus. Total phosphorus is also the key driver for algae blooms. So as I mentioned, with conditions becoming more favorable for the growth with our warmer summers, low water levels, less precipitation to agitate that water, our waterways could be more vulnerable to blooms happening, and having these high concentrations of nutrients can really help drive that as well, which could lead to even lower dissolved oxygen levels and ultimately not good for aquatic life. So phosphorus enters our waterways through runoff from things, again, like sewage, agricultural runoff, fertilizers, but it can also come from things from geological influence, so soil, rocks, as well as just decaying organic material in general. And this figure here shows the average total phosphorus across our sites for the sampling season, with the red line indicating the New Brunswick water quality guideline of 0.03 milligrams per liter. I chose to represent the data this way because if I showed it in a table like E. coli, the entire table would almost be red. So our samples exceeded the guideline 64% of the time. So most of our sites were considered eutrophic, so very productive, very rich in nutrients. And Trout Brook off Murray Road in particular was hyper-eutrophic, so very nutrient rich. It was actually almost 10 times the recommended guideline. But what was really interesting is that the two brooks that we see that did not exceed this were Timber River and Rayworth Brook. And what was so interesting about these sites? I have them pictured here, Timber River on the left and Rayworth on the right. And as you can see, both of these had dense, healthy buffer zones. So the riparian areas were full of diverse vegetation, trees, shrubs, grasses. Both of these sites also had water that was so clear you could see the bottom of the brooks. Rayworth Brook in particular was our most pristine site, I'll say. It's actually on NCC land, so it makes it a great natural, less impacted site. And it actually didn't surpass any of our water quality guidelines. So it was really a star site for using it for that comparison. Coincidentally, though, these two sites did not exceed E. coli guidelines. They also had healthy temperature and dissolved oxygen levels. So I think that really shows the importance of having that healthy buffer zone to filter out nutrients and improve the water quality before it actually enters the waterways. And also that riparian vegetation helps provide shade, giving that temperature control and keeping those dissolved oxygen levels up. A couple other interesting takeaways from our year of monitoring in the watershed. Despite being sampled at low tide, our tidally influenced sites still had brackish water when they were sampled. Speaking to RPC Moncton staff when we dropped off our samples that year, We heard that this was a common problem a lot of watershed groups were having that summer. So the water levels were actually so low that the, I guess, outflowing water from inland wasn't high enough to actually flush out the salt water with the tides. So we were still ended up sampling primarily brackish water. But what was more strange is that our Timber River site also displayed high conductivity, salinity, and total dissolved solids in July and August. But this site was not one of our estuary sites or sites we would expect to be brackish. So this requires further investigation, as it could be a sign of saltwater intrusion occurring due to sea level rise. So maybe some water is infiltrating the groundwater, and then we're finding these groundwater fed streams with brackish water present. And again, talking to other watershed groups throughout the province, this is something that they're also seeing. So it might be a future project to collaborate on to learn more. And surface water metals, we did the full suite of them. All of them were well below detection limits, aside from iron and aluminum, which actually exceeded the CCME guidelines. Except Brayworth Brook, as I said, nothing exceeded the guidelines there. But this was likely due to geological influence. The province of New Brunswick is known for higher naturally occurring aluminum, so that can enter waterways through runoff, and similar iron would be entering waterways naturally from runoff from rocks or soils. So in conclusion, how was the water quality of the watershed? While we can speculate on some of the potential causes, as I just did, or variation between sites and fluctuations and concentrations, this is really just 1 year of data collection, and a water sample is just a snapshot of water quality at that location at that point in time. You can even see with taking field duplicates, there's natural variation from taking a sample like 5 minutes apart from the same place. And again, this really pushes home why long-term monitoring is so important, but why that long-term data set is so valuable. So you can look at it and see the natural variations in water quality and see, get to know the trends over time to know what is expected. Another project we completed within the watershed the summer of 2019 was a riparian health assessment of the Gaspereau River. So this project was funded through the New Brunswick Wildlife Trust Fund. And we collected data to help provide a record of the current state of the Gaspereau River. So how is the riparian health? And with that data, it can be used to plan restoration projects for problem areas, or we can also prevent future problems by maintaining those healthy reaches of the river that we found. This was also a very exciting year because we got our EOS canoe. So that helps us with our water quality sampling as well as projects such as this one. Riparian areas are essentially your shoreline. So it's the area of land between the wet aquatic zone and the dry upland land. But they're one of the most productive and valuable natural resources. They provide a number of ecosystem services, some of which we've talked about. They provide food and habitat for both wildlife on land, but also aquatic life by providing that shade, temperature control, and other debris falling in for food. They improve water quality, so they filter out those chemicals and sediments before going into the river. Water storage, flood mitigation, erosion protection, and those deep-rooted plants that are there on the shoreline also help with recharging groundwater. So for our riparian health assessments, the Gaspereau River, the headwaters start up near Square Lake, north of Anderson Settlement. Square Lake is actually monitored by Vision H2O based out of Cap Pelé, so they have data of the water quality there. And the river winds southeast to its outlet in Port Elgin, where it flows into the Northumberland Strait. This screenshot here of the Google Earth map shows what we covered. We covered just over 21 kilometers of the river and took assessments approximately every 500 meters. As you can see, there's a bit of a gap on our map. So one of the biggest challenges of this project was site accessibility. So unlike the Tantramar River, which we assessed the previous year, we were not able to paddle the entirety of this river, as after the spring, there's really not enough water, so we were going from it being very wide and shallow to very channelized and deep. So if you didn't have a canoe to paddle through, you'd want to actually try to climb up the steep river banks and follow alongside the river because the water was going over your waders, which resulted in us really having to alternate paddling and walking for a few kilometers until we just decided to ultimately walk stretches to be more time efficient, but then it was also very time intensive. And there's also a limited number of access points to get to the river. So one of the main access points was logging roads, so off of Coburg Road, which we took advantage of to get the more inland sections of the river. But again, the logging roads became unfavorable to drive in the spring as well as the later fall when we were getting more rain. So it was a lot more difficult to access those sites as time went on. So to do these assessments, we followed the Alberta Cows and Fish methodology. So it's very accessible. Citizen scientists can do it. It's basically a series of observations on things such as vegetative covering. Are there invasive species or disturbance-caused vegetation present? How are the banks? Is there exposed soils, erosion? And so adding up all of these points, there's a ranking system. You basically come up with a final number. So you get healthy, healthy with problems, or unhealthy for your assessment stretch. And we also took in situ water quality measurements at each assessment point as well. So here's some pictures of healthy stretches of the Gaspereau River. So some indicators of healthy riparian area includes that abundant vegetation, so those deep-rooted native plants, few, if any, invasive or disturbance-caused plants, as well as the presence of seedlings and saplings for successful regeneration, and little exposed soil, bare ground, or alder banks. So on the other side, an unhealthy riparian area is highlighted in these photos here, where we can see some bank erosion, exposed soil, there's exposed tree roots, as well as undercutting from erosion. And some other factors can include bare ground from livestock or human activity, as well as a lack of preferred tree and shrub establishment. So there's not anything to really feed that regeneration. Nothing's going to grow in that area. And I guess one of the main factors that was impacting the water quality for one particular stretch was clear cutting. So for the first couple of kilometers, the river was deemed healthy with problems due to this human impact, which you can see in the Google image. And so some impacts that we saw, which kind of, I think, answers Daniel's previous question, was a lot of invasive and disturbance-caused plants were present. There was a real lack of stream bank root mass protection, so there was erosion present. The river bottom was quite silty, whereas a couple kilometers out, then it was clear. You could see the rocks on the bottom. There was also a good amount of industrial debris, so things that were left like tires, oil canisters, material scraps from erosion fencing, beams of wood that we were finding for kilometers downstream. And these logging roads, I guess, are also a popular gathering spot for campfires that we saw evidence of, so things like beer cans, food packaging. There was actually a lot of garbage that we found at the start of our assessments. Some other notable characteristics, so working downwards on the river, we found a lot of river obstructions, so whether these are beaver dams or just wood buildups, there was definitely barriers throughout the river. We also, like I said, the wide shallowness of the river in sections with low water levels. Sometimes looking at those pictures on the left-hand side, the river almost disappeared. You would forget where you were walking because there was so much emergent vegetation. You wouldn't even need rubber boots, honestly, to walk some of the stretches of the river. And we also found significant algae growth. So again, those low water levels, warm water temperatures resulted in massive stretches of the river that was covered in algae. We didn't actually get to test to see if it was cyanobacteria, but again, that's something that could be a future project to explore. So overall, we found that 58% of the river was healthy and 42% of the river was deemed healthy with problems. And no reaches of the river were actually found to be overall unhealthy, which is promising. So some recommendations that came out of this project included planting more native deep-rooted vegetation along the shorelines. So this will really help stabilize the shorelines as well as encourage further growth of vegetation. Doing a planned river cleanup where we did see that fair amount of garbage and debris as well as wood buildup throughout the river. Through talking with community members, I heard there used to be annual river cleanups back in the 90s to remove all of these things. So maybe that could be something that we organize to start back up annually. Also, I would like to revisit some of the areas of the river we were unable to access. While we were able to use the surrounding land use and Google Maps to make assumptions on the health of those sections, actually being there in person and ground truthing it is always best. So one thing that was exciting was we were actually able to address one of those recommendations in October of 2019. We partnered with Nature MB, the Shediac Bay Watershed Association, and the village of Port Elgin to plant 130 native trees and shrubs along an eroded section of the Gaspereau River. So this was funded through the New Brunswick Environmental Trust Fund. And this particular section of river is just in front of the Port Elgin sewage lagoon. So it had been identified as a risk from those storm surges, sea level rise and erosion in the climate change adaptation plan for Port Elgin. And we were able to plant these trees with the Port Elgin Regional Schools. Some classes came down and community members. And this project will hopefully reduce the vulnerability of the sewage lagoon to all of those climate change impacts. And yeah, it was really great. You can see in the middle there the erosion that actually happened the week we were supposed to do the project. A storm happened. It wasn't even a hurricane. Nothing was expected to happen, and it took out a huge chunk of the shoreline even just then unexpectedly. So hopefully those trees that we did plant can be a second line of defense now and help stabilize and hold that soil into place. So what can you do to protect your watershed? First off, you can get involved by volunteering with your local watershed organization. You can help out with some of these great projects, but otherwise there's lots you can do on your own too. So our clean, fresh water is a limited resource. Conserving is very important for guaranteeing long-term sustainability. So be mindful of water usage, get a rain barrel to collect rainwater. You can help protect water from pollution. So a lot of this is done through land use management, which could be those vegetative buffers on water courses, fencing around livestock, but also, as we've seen in our waterways, don't litter, because that's usually where it ends up. Also enhancing your watershed, so planting trees, planting things like rain gardens, which will help mitigate flood risk as well. But most importantly, enjoy your watershed. So science has shown that getting out and using the water and really enjoying your watershed builds appreciation. And before you notice, all these things are going to become second nature to you, because you'll want to protect it so you can keep using it and appreciating it. This year, what have we been up to? We have continued our water quality monitoring, the Dorchester Rockport area. We also have done stream habitat assessments of the Johnson Creek and its tributaries, North and East Brook. So similar to riparian health assessments, the stream habitat assessments take a lot of the same parameters into scrutiny. So looking at the vegetation, the state of the bank erosion, taking those in situ water quality measurements, but also looking at things such as your channel characteristics, your flow, looking at your substrate, so what makes good stream habitat. We've planted 12 residential rain gardens throughout Sackville. We got funding through TD for planting a 300 square foot rain garden in Richard Park in Dorchester. So that's pictured down in the bottom right, which was really great. Unfortunately, we couldn't have as much community participation this year because of COVID, but we were able to get some volunteers where it was such a large garden. And I guess most recently is today or this afternoon, we're doing a rain barrel giveaway, which we got some local, well, made at the Acadian Village, wooden rain barrels, so a great alternative to plastic, which have been spoken for by various residents throughout the Tantramar-Memramcook area. And then overall next steps, we want to continue doing our education and outreach. It would be great to get our citizen science monitoring back on the go once restrictions aren't quite as tight. Looking at developing an overall watershed management plan for our Chignecto watersheds, which will really help guide our next actions. So continuing our long-term water quality monitoring, further restoration projects, so whether that's shoreline restoration, tree planting, cleanups, putting up fencing, as well as green infrastructure projects. So we actually just got funding through EcoAction, so we're going to be installing 1 or 2 green roofs over the next couple of years. And also we would like to continue our work with rain gardens and depaving. So thank you for listening to me today, just before your lunch break. Also thanks to our funders, summer students, and volunteers who have made all these projects possible. I've put a link here that I guess I can also put in the chat for our full reports on our website. And my email is also there if you have any questions or want to get in contact later, but I can also take questions now. Okay, so I don't know if there's any questions. I am seeing Pamela in the question section said she would love an eco challenge for high school students in our watershed, a citizen science challenge to get them outside on their off days. I think that would be a great idea. So they were pictured in the presentation on the citizen science slide, but we have I wonder, no, I don't have any on hand. These great water rangers, water quality kits. So they have things like your pool strips, handheld probes for things like conductivity, salinity, as well as just pH strips. But you get basically all the same measurements that you would from your HANA probe or your YSI. And yeah, we have like 10 or 11 of those available that students could take out and take samples. We also have some funding with Mount Allison University, so we could continue doing the coliform samples if that was of interest as well. So there's definitely opportunities there for more citizen science challenges for students.
All right. Well, if nobody else has any questions, then I have a couple.
Okay.
So first off, how is data being used to protect and restore watersheds? So for instance, if it's noticed that there's a particular watershed that's, you know, in rough shape, is EOS Eco-Energy having conversations with those landowners around there to try and resolve issues, or are they communicating with, you know, provincial regulators to try and address some of the challenges?
Yeah, for sure. So as a nonprofit organization, we're very project-based. So every year, coming up now in November usually is when it starts, is we apply for funding for the following year's projects. And the data that we collect, so these previous years, will help us identify those areas, like you said, or even just talking to community members. We hear about issues they have. And then from that data or that information, we can then plan out projects. So how can we address this? What can we do? And then we can find the proper funding, apply for it, and then go back and actually do the restorative actions that are necessary. And as you mentioned, a lot of the time that does include working with the landowners. We work collaboratively a lot with landowners as well as other organizations. So that might be, say, teaming up with Ducks Unlimited and putting in some cattle fencing, or maybe some alternative watering ponds for livestock if that's an issue that's been identified. But that's definitely something that we work towards as an organization.
All right, and I got one or two other questions here. So what changes, and you touched a little bit on this in your presentation, but what changes do you expect to see in the data in the years ahead as a result of accelerating climate change?
Yeah, so it's unfortunate because for our particular area, we don't have any long-term data or previous data, so we don't have that real baseline of, say, pre-climate change. But with what we are already noticing is kind of that increase in temperature, which then will result in the lower dissolved oxygen, or things seeming to be more concentrated because the water levels are lower. Yeah, and then with those more extreme, more frequent rain events, we're going to be having a lot more runoff, and the periods of dryness or extended drought really hardens the soil. So then instead of being able to percolate down into the soil, all the runoff ends up just getting washed into our waterways. So we're seeing more like flash hydrology events. So we're seeing more of those pollutants actually entering the waterways with runoff, which is again why those buffer zones are so important, and having something to really help soak up and filter that all out before it gets into the water. Because once it's in the water, it's a lot harder to really try to improve that situation, especially groundwater. So saltwater intrusion is, yeah, I hope that's not happening.
Yeah, for sure. All right, and one final question. If people want to go out and get samples within their local watersheds, is there any place that they can bring them in locally to get them tested?
So unless your local watershed group is offering some sort of project, then really the only alternative is bringing it into RPC. which is located in Moncton or in Fredericton, because RPC is really where like all your municipalities are sending their water samples, or real estate agents are sending samples that they've taken of wells and stuff. So if you're taking a sample of, say, your well or water around your property, that's typically where they would be submitted. But I'd say, yeah, reach out to your local organizations, because sometimes they have those kits or they have the equipment that you can take out to at least get some preliminary data or help identify if you think there's an issue, or they might, who knows, have a partnership at a university or in-house equipment like the Petitcodiac has. So yeah, it doesn't hurt to ask ever.
Cool. Awesome. Well, thank you so much for your excellent presentation. And it's great to hear that organizations such as EOS are keeping track of the quality of our local watersheds. So if anyone would like to learn more about EOS Eco-Energy and the work that they're doing, then please do check out their website and social media. As usual, I've posted the links in the chat room. All right. Thank you, Kelly Nicole.
Thank you.